Alright, today I'm going to go over post-test study guide page 7. So it's not that long, so we'll go pretty quick. So number 41, sketch the graph of the function f of x equals 3 to the x. So remember guys, this is called an exponential function. So this is an exponential function. Because there's the variable is in the exponent. So the variable is in the exponent. And then that means it's going to be an exponential function. That means it's going to get really big really fast or really small really fast. It's kind of like the fire starters we did the other day. So remember, you can, if you're not sure what to do, the easiest way to do it every time is just make an XY chart and pick points. I recommend finding A, H, and K. So A, once again, would be the number in, like, if there was like a negative sign there. It might say like 2 times 3 or negative 3x, alright? So A is just 1. That just means it's a normal exponential function. It's not going to go, so B would be 3, that's the base. Alright? And then there's an H. H is always next to the x. There is no, alright? And K is always after it. It's B. K is also 0. So remember, your starting point is H and K plus 1. So your starting point is 0, 1. And if you weren't sure, if you didn't know any of this stuff, you could not know any of that stuff right there. You just plug in 0, it's going to spit out 1. Then I'm going to plug in, a lot of times I like to plug in, say 1 and 2, and negative 2, and negative 1 and negative 2. So if you wanted to make your graph look like this, with your starting point in the middle, that's fine, or you could do it that way, it doesn't matter. I know 0 is 1. I plug in 1, I get 3, because 3 to the first is 3. I plug in 2, I get 9. I plug in negative 1, I get 1/3. I plug in negative 2, I get 1/9. Remember, we talked about asymptotes. So there's an asymptote. It's always at y equals k. So there is a dotted line here that your graph can never go under. So that's going to be it's called your asymptote, if you can see that. So now I'm just going to graph my points. 0, 1, dot, remember that's my starting point. 1, 3, dot, 2, 9, dot, negative 1, 1/3, negative 2, 1/9. Remember, it's never going to touch that line. And it gets really big really fast. It goes to the left forever, to the right forever. That's it, done. Alright, number 42. If there are initially 4,000 bacteria in a culture and the number of bacteria doubles each hour, the number of bacteria after 2 hours can be found using the formula. So this is another thing called exponential growth. It's actually pretty easy. Even if you didn't know anything about exponential growth, you know how to plug stuff in. You just have to understand what the variables mean. T right there means time. Well, they're telling you 9 hours. So all you do is in your calculator, you do 4,000, 2 to the 9th. And that's literally the entire problem. So I'm just going to type in 4,000. Make sure you put times 2, and make sure you do 2, or if you're using your phone calculator, it's probably easier to do 2 to the 9th first. And with 2,048,000. So it's A. Explain the difference between an exponential function and a linear function. All right, linear, constant rate of change or slope. All right, so like when you have a line, right, it's always either increasing or decreasing at the same rate. Here would be an example: y equals negative 2x plus 4. That would be going down. All right, so it'd be a negative slope, but it's constant. It's always going to go right 1 down 2, right 1 down 2. Exponential, all right, changing. Changing rate of change. So it's either going to get really big really fast or get really small really fast. So it's either going to be it's either going to get really big really fast, or really small really fast. Alright, so like it could either look like this, or like that, or it could go. So here's an example: y equals 2 to the x. That's the variables in the exponent to the exponential function. And that's it. Alright, this is an example of exponential decay. Alright, because it's gonna. We know it's exponential decay because that is between 0 and 1. I don't know why I put x there. I meant to put b. So remember, because b is for the base. So a is still 1, which means it's just normal. It's not flipped or anything. Remember, if a was negative, it would flip it upside down. B is 1/5, which tells me it's decay because it's less than 1. H is 0. K is 0. Remember, H would be right there. K would be right there. We don't have any of those. So when I make my XY chart, once again, I'm going to pick, I'm going to put 0, and then remember it's K plus 1. So remember, that's an asymptote. So there's a dotted line at the x-axis saying your graph can never cross that. Now I'm going to pick some points. I'm actually going to pick, we'll see, I might play around and pick some points when I plug it in. But I'm definitely going to pick 0, 1, 2. So if I plug in 1, 1/5 to the first, I'll probably just pick -2. Yeah, that's probably, I'm just going to pick that. So I plug in 0. This is always double check. If you're not sure if you did that right, just double check. So even though I kind of used H and then K plus 1 for my starting point, remember I'm calling that a starting point. Always double check if you're not sure. You could plug in 0, it spits out 1. Then I get 1/5. Then I get 1/25. Now I plug in -1, I get 5. I plug in -2, I get 25. Remember, negative exponents do not give you negative answers. Negative exponents give you fractions. Because it's like the opposite of that. It's the opposite of repeated multiplication, so it becomes repeated division. All right. Now, so I can go -1, 5. There's a point. 0, 1. 1/5 right there, and 1/25 right there, and then we know that it's going to go really high, really fast. Now at the end I kind of messed up that graph a little bit, so I'm going to redo it, because I cannot cross that dotted line, right? It's not perfect, but it's about it. And that's it for this. I finished this whole video. Pretty quick and easy.